Michael Behe has devoted his career to the study of the design and operation of the cell. He has also written extensively on the biochemical challenge to evolution.
Most people have no idea of how small and complex cells are. A typical cell from you or me, called a eukaryotic cell, is probably 1/10 of the size of the head of a pin. And yet in that single cell, there are about 3 billion units of DNA making out the chromosomes. And those 3 billion units make the molecular machines of the cell, literally machines that make the cell work.
With computer animation, we can enter the cell. Here, the staggering complexity of its molecular machinery is clearly seen.
It's like going into an automobile factory. The factory has a large number of machines. The parts have to fit together in very specific ways to do their jobs, and if things go wrong, the cell is in big trouble. And just one cell is enormously complex, but humans, you and I, are made from trillions of cells, and those trillions of cells have to fit together in the right way and do their own job. Darwinism was a lot more plausible when we were thinking about globs of protoplasm than it is when we're thinking about molecular machines.
Each of these biochemical machines is a masterpiece of engineering and nanotechnology. They are essential to functions as vital and diverse as vision, photosynthesis, and the production of energy in the cell. Michael Behe has studied several of these machines, including the flagellum, a remarkable rotary motor.
I remember the first time I looked in a biochemistry textbook and I saw a drawing of something called a bacterial flagellum with all of its parts in all of its glory. It had a propeller and the hook region and the drive shaft and the motor. And I looked at that and I said, that's an outboard motor. That's designed, that's no chance assemblage of parts.